We see AIs doing all this incredible stuff, right? From absolutely mastering the most complicated games you can imagine to even helping discover new medicines. But have you ever stopped to wonder how they actually learn? I'm not talking about being spoon fed millions of rules by a programmer. I'm talking about figuring things out completely on their own. So, how does that even happen? How can a machine go from basically mashing buttons at random to playing a video game with a flawless, professional strategy, a game it's never even seen before? Well, the answer lies in a fascinating area of AI called reinforcement learning. And the core idea? It's actually super simple and very, very human. An AI agent learns pretty much the same way a baby learns how to walk. It tries something, it falls down, that's a little penalty. Then it tries something else, takes a wobbly step. Hey, that's a reward. And it just keeps doing that thousands upon thousands of times until it finally masters the skill. It all boils down to this simple but really powerful four-step loop. First, the AI agent takes a look around and observes its situation. You can think of it like seeing a single frame of a video game. That's the state. Second, based on that, it takes an action. Third, the world or the game responds. It gives back a reward, like points, or a penalty, like losing a life. And fourth, it learns from that outcome and just repeats the cycle over and over millions of times with just one goal in mind: get the highest score possible. Okay, so if the loop is that simple, you might be wondering, why was this so hard for so long? Well, it's because this seemingly easy process throws up two massive, towering hurdles that are incredibly difficult for a machine to get over. So the first big problem is what's called the credit assignment problem. I mean, think about it. You're playing a really long game, you make thousands of moves, and right at the very end, you win. Fantastic. But which of those thousands of moves was the one that really mattered? Was it the very last thing you did? Or was it some clever move you made 5 minutes ago that perfectly set you up for victory? That, right there, is the delayed consequences problem. And it is a massive hurdle. Take a classic game like Montezuma's Revenge. The agent might pick up a key. It gets 0 points for that. No immediate reward at all. But 10 minutes later, that exact key is the only thing that lets it open a door to get the final treasure. The AI has to somehow connect that action to a reward that happens way, way down the line. And that brings us to the second massive challenge, something called the explorer's dilemma. Okay, so on the one hand, the AI wants to exploit what it already knows works. If it found a move that reliably gets it 10 points, it should just keep doing that, right? Makes sense. But what if there's some other move, something it's never tried, that could lead to a giant 1,000-point bonus? To find that, it has to explore. It has to try new, random seeming things that might just lead to nothing. And balancing when to play it safe versus when to explore is incredibly tricky. So for years, these two problems basically meant that reinforcement learning was cool in theory, but only really worked for simple little tasks. And then in 2015, everything changed. Researchers at DeepMind published a paper showing off a system that could learn to play old school Atari games at a superhuman level. And get this, it started with nothing but the raw pixels on the screen, just like we would. I mean, this was a huge leap forward. After decades where progress was kind of slow and steady, the big breakthrough came from combining that classic trial and error learning loop with modern deep neural networks, the same kind of tech that's used for recognizing images. This mix created a total paradigm shift. Suddenly, the AI could literally see the game like a person and learn directly from what it was seeing. And the results? Well, they were just staggering. When they averaged its performance across 49 different Atari games, the AI didn't just match a good human player, it scored 241% of the average human score. It was finding tricks and strategies in these games that people who'd played them for years had never even thought of. So you've got to be asking, how did they do it? How did they finally crack those huge problems of delayed rewards and the explorer's dilemma? Well, it came down to a couple of really clever tricks that made the whole learning process stable enough to work. The first one is called experience replay. So instead of the AI making a move, learning from it, and then immediately forgetting about it, it stores hundreds of thousands of its past moves, the good, the bad, the ugly, all in a big memory bank. Then, to learn, it just pulls random samples from this memory. This is so important because it breaks the connection between one move and the next, and it lets the agent learn from a really diverse mix of its past experiences all at once. Okay, the second trick is called fixed cue targets. Now stick with me, this gets a little technical, but the main idea is actually pretty simple. It's all about stopping the AI from chasing a moving target.
See, the AI is always updating its own opinion about how good each move is. If it tries to learn based on those constantly changing opinions, things can get really unstable and spiral out of control. So the solution is to have it learn by comparing its current guess to an older, saved copy of its opinions. That gives it a stable, fixed target to aim for, which makes a world of difference.
But really, this was never just about getting high scores in video games. Mastering a game from just pixels was the proof that an AI could learn really complex skills in any environment, as long as there's a clear goal. And that ability, well, it has enormous implications for the real world. Today, these very same ideas are being used to teach robots how to pick up and handle objects they've never seen before. It's used to optimize which ads you see online to make them more useful. It's even being used to help doctors design personalized medical treatment plans for patients. It's really about creating systems that can figure out the best strategy in any situation with a clear goal.
And that really brings us to the big final question. We've watched an AI go from knowing literally nothing to achieving superhuman skill in dozens of really complex, different worlds. So the question isn't really if an AI can learn on its own anymore. The real question is, what are we going to ask it to master next?